All right, cool. We can get started. Hey, I go by Sauce. I'm the protocol engineer at the UniSwap Foundation. I've worked quite extensively on like the core code base of UniSwap v4, and today's talk is really just like kind of like an intro, but also just me just spewing some fun and random ideas around UniSwap v4. So this is me on Twitter. I'm also known to be like this like shit poster on the GitHub. So if you have ever crawled the pull requests, there's some funny stuff in there. Okay, quickly. So v4 is more than just hooks. It's kind of like a big feature in v4. But we have a singleton design. So what that means is it's a single contract where all the tokens are sort of held and custodied by the single contract versus like the v3 design. This is a lot more gas efficient. And because of this singleton design, we have this thing called flash accounting, or some people also call it like deferred balance accounting. And the idea is like you can stack a bunch of operations that create like credits or debits. And at the very end of the transaction, you do that final token settlement. Whereas normally, like if you were to swap and then add liquidity, you would have to swap, do token transfers, and then add liquidity, another set of token transfers. But with flash accounting, that all just kind of happens at the very end. ERC 6909, it's essentially a wrapper for ERC20s. It allows you to keep your ERC20s within the core contract and allows you to efficiently trade value back and forth. So it's really useful for like MEV bots or like high frequency traders. Another feature is native ETH. So in v2 and v3, you have to wrap your Ether in order to trade ETH. But in v4, we also directly support the native ETH token. Also, again, for gas efficiency. There's this new thing in v4 called donations. And it's related to liquidity provision, where you can kind of donate revenue to in-range LPs. It's a mechanism possibly for like value redistribution. So that's another interesting aspect of v4. And then the last thing with v4 is like there are no fee tiers. You can have all sorts of different fees, like 4 basis points, 22 basis points. And then another area that we see developers engage with is really dynamic fees. This allows developers to freely express and change the fee up or down. There's obviously limits to it, but again, it's not hard-coded by the protocol at all. I think there's some other AMMs out there where they support dynamic fees, but they have like some hard-coded formula to it. But in v4, it's all set by the developer. And then lastly, hooks, which is kind of like the majority of our talk today. So what are hooks? Hooks are a way to arbitrarily attach valid solidity in the swap lifecycle. The swap lifecycle is more than just swapping, right? It's like the whole end-to-end process. So like whenever a pool gets created, like you could check and verify certain things, or after a pool gets created, you can kind of configure it. During liquidity provisioning and liquidity modification, you can also run logic such as, checks or modifications. Whoops. Why does this not? Okay, cool. Sorry. And then, of course, you have swapping. So before a swap happens, you could update the dynamic fee. You can modify liquidity to concentrate liquidity. And then after a swap happens, you could write like storage for like an oracle. And then also, as I mentioned in donate, I haven't seen a lot of hooks around donate, so that is also like another interesting area to explore. And so this is what hooks kind of look like. It's what you would expect. So before a swap happens, it does this check to see if the pool is configured for it. If before swap does exist, it makes this external call to your hook contract. So where it pulls off to the right, that's a totally separate contract that you would implement, and then it returns back to the core contract to run the swap logic. This is what the code looks like. I'll do kind of a deeper dive, but again, like a hook is really a deployed contract that adheres to a certain interface where you can then add some logic to the swap lifecycle. And then quickly, it's worthwhile to explain the difference between hooks and pools. A hook is a pool, but a pool is not always a hook, is the way to describe it. And so what I mean by that is pools are simply independent, unique sets of liquidity positions. It's a collection of two assets to trade against, right? Pools have at most one hook contract. A hook contract implements multiple hook functions. And for these hook functions, like before swap and after swap, you can mix and match and choose as you want. If you use before swap, you're not excluded from using after swap. You can, you could use all of them. You could use one of them. It's totally fair game. And just to highlight, where hooks and pools are related to each other. So this is the initialize function. So if you're creating a pool, you specify the pool key and its starting price. The pool key, which again uniquely identifies a set of liquidity positions, is defined by its trading pair, so the two currencies, its fees, some configuration parameter called tick spacing, and then as you can see, hooks. So every pool has at most one hook contract. And then so just diving a little into before swap and how hooks work. It's kind of what their name implies. Before swap gets executed, before swap happens, after swap gets called after a swap happens. It's worth noting here that in before swap and in after swap, you get access to the pool key. And so within before swap, you have knowledge on what trading pair you're working on, the direction of the trade, and the size of the trade as well. And so you can, in theory, design one hook contract that services ETH USDC, ETH Tether, ETH BTC. So one hook contract can service and facilitate, different trading pairs. Another interesting data that's passed to after swap is the swap result. So you get access to the input amount as well as the output amount. And so if you wanted to do oracles or maybe different value redistribution mechanics, you would have access to the volume. Same thing is true for liquidity hooks. It's split into 4 different functions here. But again, sort of as their name implies, it's logic you can execute during the liquidity lifecycle. Now on to the fun random ideas that I have around hooks. So obviously, as I mentioned, we have dynamic fees, and there are ways that hooks can actually charge external fees. We call them hook fees. And so there are ways to do value redistribution or different sort of incentive schemes for incentivizing either swappers or liquidity providers. There's a whole body of research from Dan Robinson. And so there are some ideas around building an AMM that's resistant to sandwich attacks. And these slides are a little bit old, but I think 2 weeks ago, Dan Robinson had a paper on prediction markets, and he essentially came up with this really fun custom curve that would be very, very conducive to providing liquidity on prediction markets. Man, why is it doing that? Whatever, I'm just going to roll with it. There are some things you can do with automated liquidity management, as I said. So maybe in before swap, if you observe a large trade size, you can concentrate liquidity. With V4, we can directly support rebasing tokens, not natively, but you can roll a hook to support it would do automated wrapping. So for Lido staked Ether in before swap, let's wrap it into wrap staked Ether. You could also design custom curves for different asset classes and rebasing tokens, and that's sort of the 2 big areas and the 2 big themes that the foundation is super excited about related to hooks is one, something that improves LP profitability, so around fee optimization or liquidity management. And then the other side of the things that we're interested in are hooks specifically designed for certain asset classes and asset types. Another big research area is application controlled execution. I think people also call it app-specific sequencing or ASS. And this is kind of like related to, again, Dan Robinson, where like in a hook you can, in theory, like control the order of transactions that are being fulfilled. And so you could maybe order the transactions based on some auction or some sort of fee. And then, so that's for hooks. And then for V4, more generically, because our prizes are not just hooks, but also it includes V4. There's liquidity mining with subscribers. This is like a new feature that's a little bit different than V3. Maybe something around like creating oracles for liquidity positions. Those don't really exist yet, and that's kind of like a cool, fun project. Like I said, with these like 6909 tokens that are like minted by the core contracts, maybe like building some sort of like staking mechanism for these would also be pretty neat. Developer tooling, of course, is always like a very fun topic. This could be anything from like testing kits, I think, and like back testing, like LP performance, just anything to like really streamline and like supercharge like the hook building experience. Are some really, really great ideas to build in V4. Another area is like indexing as well, like maybe setting up a ponder schema would be really cool for us. And then so lastly, I guess just to go into our like prizes. So our biggest prize is hooks. If you just implement a hook that has a dynamic fee or a custom curve, or some sort of like fun like value redistribution thing like anti-just-in-time. And then our second category is around integrations, kind of like anything where you might be using V4 as a dependency for your project, but you're not directly building a hook is totally eligible. And then our last category is obviously for Unichain. It's just, build some fun DeFi app on Unichain. And that's me on, that's me on Twitter and Telegram, so you can reach me there. We are super active on the Discord. We have docs. If you are interested in building a hook, I recommend our V4 template. It sets up the dependencies, gives you a boilerplate hook. The tests are all set up. So that's a really, really nice place to start. And then, I can open up the floor for any questions. So his question was, for the UniSwap front end, if you want to swap through a hook, do you call the hook directly or a contract? That's a good question. You could call the hook directly. It's not like a very common pattern. The hooks are sort of like abstracted away such that like, in theory, like if I wrote a swap router or Uniswap Labs has a swap router and they sort of specify that the trade should go through your pool, it will automatically like execute your hook logic for you. But you could, in theory, design your hook in a way. So the question was, if for the hackathon you make your own hook, do you have to roll your own swap router? No, you don't have to. We have universal router, and I believe I will be merging documentation on it. And then there's a like really, really simple test router that's included in V4 template, and it has like an example for how to use it. And that's good for like a single pool trade. Like you can like directly just trade on your hook.
Just a really simple one. Just 'cause I've never done it before. Just wondering, how do you connect a hook to like a pool? Is it you just need to like register the hook? The address of the hook? 'Cause it's a separate contract.
Yeah. So registering a hook. So whenever you create a pool, you specify your pool key here. And then inside the pool key, you have iHooks, which is, it's an address. So whenever you create a pool, you specify the hook address.
Okay. So you like deploy the pool manager by itself, and then in that you register pools. Is that how it works?
Yeah, correct, yeah. So before you create a hooked pool, you have to deploy your hook address. It's an entirely separate contract. And then, so you register it on the core pool manager. Like this is the core contract. And as part of like registering or creating this pool, you specify the hook address.
Cool, thanks.
Cool.
So general question, like if we all here build a hook for a pool, we all create separate pools, maybe for the same pair. How does the liquidity doesn't segregate? Like,
Yeah, I get this question a lot. So, yeah, in theory, a trading pair ETH USDC will exist as a lot of pools. I think there's generally market forces that, you know, where liquidity providers will naturally sort of congregate around like the best performing pools, like the pools that get the most volume. In general, it's a problem that does exist. We don't expect it to materially exist. I've sort of recommended developers that if you are trying to compete on ETH USDC, you might have a bad time. But essentially, like one of our categories, right, is like designing pools and tokens together, right? Hooks and pools, or hooks and tokens together. And so, like, if your token is only predominantly traded on this one specific hooked pool, then you'll get like most of the volume and most of the order flow.
thank you.
I think there was a question in the back, the gentleman.
Thank you. Am I right? So there is no way to remove already existed pool or add to existing pool some hooks?
Yeah, there's no way to remove a pool after it gets created. I mean, I guess if there's no liquidity there, then it's technically like removed. If you initialize a pool, there's no way to attach a hook afterwards. It's like at initialization that the pool and the hook are coupled together. Cool. If there were no other questions, I will be hanging out at the booth. So yeah, come and find me.